So you can start the session, sir.
Hi, good evening, everyone. Hello. Thank you, ma'am. Hi, hello, everyone. Yesterday we yesterday we were discussing about how to check if a function is continuous at a point or not. Okay, we had discussed this about how to check if a function is continuous at a point. So for that, I had told you that you can check the left hand limit, the right hand limit, and the value at that particular point, and all of them should be equal, right? Left hand limit should be equal to right hand limit, should be equal to value at that particular point. If we are talking about, let us say, any point x is equal to x naught. Great, everyone. You remember this? Everyone? Everyone? You're not there. What happened? So yesterday, we were just doing one small question. In this question, we were given, it was given to us that f of x is equal to tan of pi by 4 plus ln x raised to 1 by ln x when x is not equal to 0. And when x is equal to 0, it was given some constant value c. So it was given to me that this function is continuous. So it was asking me to find the value of c. So yesterday, as we had discussed, very easy. We know that the function is continuous at a point. We know that the left hand limit is equal to the right hand limit is equal to the value at that point. Okay. So we are talking about x is equal to 0. So f of 0. Can anyone just tell me what is the value f of 0? When x is equal to 0, what is the value of f of x? Anyone? Who will tell me? Shriram, Bhavna, Gayatri, Shivani.
0.
If x is equal to 0, what will be my value of function
C, sir.
f of x?
C.
Will it be 0? Why will
C.
it be 0?
C.
I am
Answer.
talking about how
C,
much?
sir. C.
C. Great.
Constant.
It is c, right? It is given to me. If x is equal to 0, f of x is equal to c, right? So it will be c. Okay, great. So basically, I know that left hand limit and right hand limit, both value will be equal to c, right? I know this. So it is just a very small job for me to calculate the value of left hand limit and right hand limit. So I know this function and I just need to calculate the left hand limit or the right hand limit. So I can take limit x tends to 0 of this function that I have over here. See, if x is tending to 0, is x equal to 0 or not? Tell me. Who will tell me? Gayatri.
Sir,
If
it is not.
x is tending not equal to 0, so it will follow this function, right? Tan of pi by 4 plus ln x raised to 1 by
Yes.
ln x. Yeah. So x tends to 0, tan of pi by 4 plus ln x. Sorry, just a minute. Uh, x is equal to 1. Okay, not 0. Just a minute. Just a change in the value. Fine. So it is x not equal to 1. So the same thing we are doing for 1. Okay. So this thing will change to 1. X tends to 1. Whole raised to 1 by ln x. So can you tell me if x is tending to 1, where is ln x tending to? Ln of 1. What is ln of 1? Natural log
0.
of 1.
0.
Great.
0, sir. Same, sir.
So where will 1 by ln x go to? 1 by ln x?
Infinity. Infinity,
Great,
sir.
infinity. Which form is this? Which indeterminate form is this?
1 raised to infinity.
Great. 1 raised to infinity, right? Because if you substitute ln x as 0, so you'll get tan of pi by 4. What is tan of pi by 4? Tan of 45 degrees. It is 1. So 1
Sir.
raised to infinity. Yeah, 1 raised to infinity. Great work. So how do we solve 1 raised to infinity? E raised to f of x minus 1 into g of x, right?
Yes, sir.
1 into g of x. Right, everyone? Everyone, is this correct? E raised to this thing, right?
Yes, sir.
So how will you solve this? Tell me, how will you solve this thing? We have solved this limit earlier, if you remember. So in this thing, like you have just got ln x and ln x everywhere. So you can convert it from ln x to x. So how would you do that? You will assume a function, assume a variable y that is equal to ln x. So if x is tending to 1, where is y tending to? Tell me. If x is tending to 1, where is y tending to?
0, sir.
Hmm.
0.
So it is limit y tends to 0 tan of pi by 4 plus y minus 1 whole divided by y. Do you all agree with this, everyone?
Yes, sir.
So we have solved this limit, right? We have solved this limit earlier. Anyone remembers how we solved this limit? We have solved this one, yeah. I don't know why you are not able to get it. We opened this using tan of a plus b. What is the formula for tan of a plus b?
Tan A plus tan B by 1 minus
By
tan A.
1 minus tan a tan b. Okay, great. So this is how we opened this thing. And when we opened this thing, so like we have done this earlier. I don't know if any one of you remembers or not. In the previous week only we had done while we were solving for limits. So you can open it, right? Tan of a plus b. So it is 1 plus tan a tan b by 1 minus tan a tan b. So here tan of a is 1 actually, minus 1 whole divided by y. So in the numerator you will get 2 tan y by 1 minus tan y into y. So this tan y by y, when y is tending to 0, what will it be? What will it be?
1,
Tan
sir.
y by y. Great. So it is 2 divided by 1 minus tan y. And tan y is 0. So answer is 2. So what is the value of my limit? My value of limit.
Sir,
What will it be?
E raised to 2.
Great. We have done this one earlier. Remember everyone?
Yes, sir.
I don't.
Yes,
Okay, great.
sir.
So what will be my value of C? What will be my value of C?
Same, sir. E raised to 2.
Great. I guess you all were not present yesterday, right? Yesterday only Vignesh was there and Sriram was there. Gayatri, Bhavna, Ashrita, you were not there, I guess. Okay, anyways. So, uh, okay, so this was all about continuity at a point. So we have discussed continuity at a particular point. Now let us discuss continuity in an interval. So for example, you have been given a function f of x and you have been given an open interval a comma b. So in order to check if a function is continuous in this interval, so easily like you can very easily say that it has to be continuous at every point. If it is continuous at every point in a comma b, in every point between a and b, so I can say that it is continuous in that interval, right? It's really simple. So yesterday we were discussing about how to check graphically if a function is continuous or not. So for example, you have been given a graph, right? Graph of a function. So let us say any something like this, it is given to you. And between two limits, so limit, I mean, not the limit that we discussed. Limit means two values of x. So for example, this is your starting value x is equal to a, this is your starting value x is equal to b. So starting from x is equal to a and going till x is equal to b, if your plot can go like you, if you can plot the whole curve between x is equal to a and x is equal to b without lifting your hand even once. So you start from this point and you go till the last point without lifting your hand. Okay, a very layman explanation. If you can complete the curve without lifting your hand, we say that the function is continuous. This is what is meant by the graphical meaning of continuity. So continuity would mean that you can complete the whole curve without lifting your hand. This is what it means. Fine. So it would mean that a function is continuous in this whole range. Okay. So let us just discuss a few cases or a few examples of functions that we have done till now. So if you all remember, what functions have we discussed till now in relations and functions? We have discussed many functions. So first of all, very easy, polynomial functions. So polynomial functions are continuous at every point. And it is really simple to check. Like you have a polynomial, like you have got f of x is equal to a naught plus a1x plus a2x square plus so on, an x raised to n, right? So like you take any value of x, you take x is equal to some value x naught. So either you take limit x tends to x naught minus, or you take limit x tends to x naught plus. Is this an indeterminate form? Who will tell me? If I substitute, if I want to substitute x is equal to x naught, is this an indeterminate form?
No,
I
sir.
have any value. This is not an indeterminate form, right? Yeah, this is not. Right? I can substitute any value I wish to, because there is nothing, there is no division to it, there is no power to it. So obviously, like it is a polynomial function, so it is determinate. There is no indeterminate form in this case. So I can just easily substitute my value of x is equal to x naught. X naught can be any real value. So polynomial functions are continuous at every point. Okay. Moving ahead, polynomial functions. After that, we have y is equal to sine x and y is equal to cos x. So if you look closely at these curves, so I mean, like this can be proved in the curve way also. So like you pull out the curve of sine x. So starting from minus infinity to infinity, you can plot the whole curve without lifting your hand even once. Start from the leftmost side. Start from the leftmost side and you can complete this whole curve without lifting your hand. And the same goes for cos x. So what can I infer about this? What can I infer about sine x and cos x? Continuity of sine x and cos x. Tell me. If I can complete this whole curve without lifting my hand, what can I infer? What can I conclude? Who will tell me? Bhavna, Shriram, Gayatri. Can I say they are continuous at every point?
Yes, sir.
Right? I can complete the curve without lifting my hand. So yeah, they are continuous. Now let us discuss one case, or let us take it as a question. So you have got f of x is equal to tan x, and I want you to discuss its continuity. So tan x is basically sin x divided by cos x, right? Sin x divided by cos x. And I want you to tell me, is it continuous at every point or not?
No,
So
sir.
yesterday, okay,
Sir.
great. No. Why do you think so? Tell me.
Its graph is also not continuous.
Okay, great. So that sounds great. That it looks something like this, right? And then it starts again from bottom, something like this. So yeah,
Yes.
correct. Graphically, you are absolutely correct. Uh, can you go a bit into the theory also? Just see sin x divide by cos x as a theory. So see, yesterday we were discussing about continuity. So I had told you that one function divided by another function, if f of x and g of x both are continuous, So f of x divided by g of x, if I take it as a whole complete function, it is continuous only if denominator is not equal to 0. Can you tell me what will happen if denominator is equal to 0? What will happen if denominator is equal to 0? So this whole thing will be actually an indeterminate form, right? It will be divided by 0. So anything divided by 0 is not defined, right? Everyone,
Yes, sir.
do you all agree? So that is why. So is there a place where cos x is equal to 0?
Yes, sir.
Yeah, right.
Cos
There are many places.
cos 90 degree.
Yeah, great. 90 is there. After that, we have we have pi by 2, we have 3 pi by 2, we have 5 pi by 2, and so on, right?
Yes,
Infinitely many places. So at each point, at every point where cos x is equal to 0, my f of x tan x will be discontinuous. Okay, great work. So we have discussed two types of functions. So now we will be discussing about exponential function. Exponential function means y is equal to a raised to x. So how does the curve of a raised to x go? Something like this, right?
yes, sir.
Yeah. So starting from minus infinity going till infinity, from minus infinity to infinity, I can plot the whole curve without lifting my hand. So I can say it is continuous. Right, everyone?
Yes, sir.
Yes, sir.
Great. Great. So A can be anything. A can be anything, but like A should not be equal to 1. This was the basic criteria. A should not be equal to 1. Great. Now let us think about ln x, natural log of x. So if you all remember, how is the curve of ln x? Okay, it goes something like this. It is the mirror image of this curve along the line y is equal to x. So you have got this line y is equal to x that makes 45 degree with your x-axis and y-axis. Okay, so it is the mirror image of this thing. So can you tell me? So starting from it's what is the domain of this function? Domain of ln x. Anyone? No one remembers, I guess. Relations and functions, we have discussed this in detail. What is the domain of ln x? Domain means what? Gayatri, what is meant by the word domain? Bhavna, Sriram.
Sir, inputs
Hmm. What
that
are the
we
set of valid inputs that you can give to the function? So can you tell me what is the set of valid input that you can give to this function? Don't remember. You can look at the curve. Like if you look at the curve, you can tell me what values of x do you see over here at which the curve is being plotted. What are the values of x at which this curve has been plotted? Right? It is 0 to infinity. Right? You can see that starting from 0 to infinity, your curve is plotted. Right, everyone?
yes,
Got
sir.
it? So, like you could have told it from the graph also. I have given you the graph, so you could have told this to me. So, starting from 0 to infinity, that is its domain. So, starting from 0 and going till infinity, the curve can be plotted without lifting my hand. So, it is continuous in its domain. Right? Now, if you ask me, sir, ln x is not continuous at a value that's negative. So, for example, you take any negative value and then ask me, is it continuous at that point? So, like, obviously, it can't be continuous because it does not exist at that point. A function that does not exist at a point, so we can't raise the question of its continuity. A continuity's question can only be raised if a function exists at some point. So ln x will not exist, or logarithm of x won't exist for negative values of x. So there is no question of its continuity. Right, everyone? Continuity will only exist when like the function should exist at that value of x. If the function is not existent, no question of. Okay, great. So let us look at a few cases wherein now I'll start with red. So let us start first of all with greatest integer function. So can you tell me what is the plot of greatest integer function? What did we call it? Greatest integer function. So greatest integer function's plot was something like this, stepwise function, right? We used to call it a staircase function, something like this,
Yes, sir.
right? Right? Everyone? Okay. So for the time being, I can assume, like, I assume x belongs to any value integer I, okay? Any integer I. So if x is equal to I, exact value integer, can you tell me what will be the value of fractional part of x? Fractional part of exact integral value.
I, sir.
How much? Great. Right? If I put fractional part of any integer, sorry, if I put greatest integer of 5, GIF of 5, GIF of 6, GIF of 7, any particular integer, it will give me the same integer value. And if I take a value that's just greater than that integer, what will it give me?
I only, sir.
Great work. And if by mistake I slip down and take a value that's just smaller than I, what will it give me?
Sir,
Hmm? Tell. See, now we are talking about a value that's just smaller than an integer. What will it give me?
I
How much?
minus.
Great. I minus 1. So this is my value at that particular point, I. This is my value at I plus. So this is my RHL, right hand limit. And this is my left hand limit. So my left hand limit, right hand limit, and the value at that particular point, all three are not matching. If you see, my right hand limit and my value at that particular point, both are equal to I. But my left hand limit is I minus 1. So it is not matching. So what can I infer? Tell me, what can I conclude from this thing? It is not continuous, right?
Yes.
Yes, is not something.
Not continuous at integer points. At all values where x is an integer. And this same thing will happen for one more similar function. Can you tell me what is the immediately similar function to greatest integer function? What is it? Just think, like, its name is also similar. The
Integer
last two words are same. Yeah. What is it? Tell
lowest
me, what is it?
function.
Least integer function. Great. It's denoted something like this, right? The same thing will happen here also. Do you all agree?
Yes, sir.
Yeah, the same thing will happen here also. So if you take an integer value, it will give you the same value. But here the opposite thing will work. Like, obviously it will be discontinuous, but it will be discontinuous because of a different reason. The value at that point and the left hand limit both will be equal to I. But over in this case, in the least integer case, your RHL will have a different value. So let us try this. So you take x to be an integer I. So tell me, what will be the least integer function of I? What will it be? Great. Now you take left hand limit. Take left hand limit. That means a value that's just smaller than I. Where will it get you?
I
I,
minus.
I
Are you sure?
only
What is
I.
what is? Yeah, it will be I. Do you know what is like I? What does least integer function do? What does this function do? It will bring you to the. It will get you to the top, right? It gets you to the top. So what about I plus? What will happen now? You have
Sir, I
crossed the
plus
integer mark. I
I plus.
plus 1. Great. It will get you to I plus 1 because it makes you go to the immediately higher number if you are not at an integer currently, right? So it will make you go to the immediately top number. Great work. So see what was happening here is my value at that point was equal to my RHL and my LHL was not equal. But over here, LHL is equal, but RHL is not. Okay. So the opposite thing is working. Great work. So great. So we have got y is equal to fractional part of x. What will happen over here? What will happen? Anyone? So again, let us take an first of all, let us just draw its graph. Its graph is something like this. I hope all of you remember. If not, go and revise as soon as possible. Everyone remembers this is how the curve, fractional part of x. Sofyan, can you tell me what is fractional part of x? Sriram, Sravani,
Sir, it is
what does
0.
it give me? Nani, what is fractional part of x? Like the function, what does it give me? If I input any number to it, what does it give me? Okay, so like taking a case, I have input 5.7. What will it give me?
Values
5, sir.
How much?
0.7.
5.
Hmm. So it basically gives me the fractional part. That
Um,
means it gives me the decimal value of the function, right?
yes, sir.
Decimal part of the function. Okay. So again, we will take one small case. So let us assume that x is equal to an integer. So it is equal to an integer, exactly equal. So can you tell me what is fractional part of x equal to?
0, sir.
Great work. Let us just take right hand limit and calculate I plus. What will it be equal to? What will be my fractional part equal to? Tell me.
0 point something.
Uh, okay, great. But what will be the limiting
5,
value? We have
sir.
discussed this. How much? Okay, so like I know you are getting a little bit confused. See, since we are talking about I plus, so this means it is an integer, and we are talking about a number that's just larger than an integer. Okay, so like what will it give me? The fractional part. What will be the decimal value?
Greater than I.
Greater than?
I, sir.
No,
Greater
sir.
than I. No, like the fractional part only gives me the decimal of the
Greater
function.
than 0, sir.
It will be greater than 0, correct? The value is greater than 0. But in the limiting form, what is the value? We have
Less than.
discussed this earlier. No, I'm not asking, like, it has a numerical value associated with it. Okay, so I'll just take you one through a very, very small case. So see, for example, you assume a case x is equal to 5, okay? X is equal to 5 plus, okay? So basically, you are talking about a number that's just greater than 5. Okay, a number that's just greater
0.
than 5.
0.1, sir.
Okay, are you sure it will be 0 0.1? 0 0.1 is a very large value. I am talking about a very, very small number, limit, right?
Zero
What is meant
point.
by the word plus? See, okay, so it will be something like this, right? Do
Yes,
you
sir.
all agree? It will be something like this.
Yes,
So
Yes,
sir.
what will be the fractional part of this thing? What will it be? 0.00000001. Do you all agree?
yes,
Yes.
sir.
Everyone? How many zeros do we have over here?
Infinities.
Great.
Infinity
So what
zeros.
will be the limiting value? So what will be the limiting value? The limit value of the limit. What will it be?
Infinity plus
Infinity.
Sir, is it 0?
0.0.
It is zero. It is zero, right? Because you have infinitely many zeros and then you have a one.
Yes,
right?
sir.
Yeah. Got it, everyone?
Yes,
See,
sir.
what is meant by the word right hand limit? Right, if I'm discussing about right hand limit at a point, so you can just think of it. Right hand limit means, we have discussed this earlier also, that right hand limit means I'm talking about the immediately next real number. So for example, I am taking right hand limit of 5. So I am asking you, what is the immediately next real number after 5? Can anyone tell me? Who will tell me? Uh, Shriram, what is the immediately next real number after 5? I have a value 5 on the number line. Here I have got 6, here I've got 7, here I've got 4. What is the immediately next real number to 5? I've got this number 5. The immediately next real number. Gayatri, Amani, who will tell me?
0.001.
Point, you mean 5.001? That's it?
No,
No,
sir.
So there will be many zeros, right? Many,
will
many
Yes,
zeros.
yes, sir.
Yeah, many, many, many zeros, like uncountable zeros,
yes, sir.
and then a 1, right? So what is the limiting value of this thing? We have discussed this. Limiting value means, what will be the limiting value of this thing? It will be 0,
Yes, sir.
right? Yeah,
This is 0.
great. Now let us discuss left hand case also. So in the left hand case, your x is equal to I minus. Okay. Your I, it is I minus. So I minus means we are discussing about a number that's just smaller. That's just smaller than an integer. So you've got this integer I over here. You have got I minus 1 over here. And we are discussing a number that's just smaller, the immediately preceding real number to I. Now, can you tell me what will be the fractional part of x?
0, sir.
0. No. What is the fractional part of 0.9999? What is it?
1, sir.
It is 0. It is 0.9999. Okay, great. 1. In the limiting form, it is 1. Absolutely correct. Everyone got it? Why it is 1?
Yes,
Yes, sir.
sir.
Yes, sir.
No. Anyone who has any doubt why it is 1? Anyone, any doubt why it is 1? Right? Because your distance from this point and the immediately preceding integer is 1. In the limiting form, it is 1. So that is why this is equal to 1. So see, if x is equal to I, it is 0. In I plus, it is 1. But if it is I minus, then it is 1. So 0, 0, and 1, they are not matching. So what can I
Dad,
infer? What
Dad,
can
Not
I infer?
వీళ్ళ
It is
జిందబామ్
not
ప్లస్
continuous.
అంట అదే జింద ఫిల్మ్
It is
జందబామ్
not
అది
continuous. Sir.
No, it is not
Fraction
continuous,
part
right?
of x.
yes, sir.
Y is
Not
equal to not continuous.
Not continuous. Sir. Y equal to fraction part of x.
Not continuous at integers. Right, everyone?
yes,
Great.
sir.
Okay. So let us just discuss a few questions now. Even though like we have done it earlier. So I have got a function f of x that is equal to greatest integer function of x by 3. Okay. X by 3. And x is belonging from 0 to 30. And it is asking me, what are the discontinuous points? What are the discontinuous points? So for one case, let us just take it GIF of x only. Okay. For the first question, I'll keep it easy. After that, we'll start one level further. So you have got f of x that is equal to greatest integer function of x. X is belonging from 0. X is belonging from 0 to 30. And it is asking me the number or at which points it is discontinuous. It is a really simple question. So tell me, what are the points at which points is greatest integer of function, greatest integer function discontinuous? So you can go up and see also if you wish to. Greatest integer function is discontinuous at integer points. Of 0 to 30, what are the integer points you have? 0 to 30, what are the integer points you have? Who will tell me?
30, sir.
1, 2, 3, 4, 5, and so
Up
on.
to 30, sir.
Up to 30.
Great. Will it be discontinuous at 0 also?
No, sir.
No, sir.
It will not be
No,
discontinuous at 0.
we
Okay,
will
great.
not get indeed.
What about 30? What about
Continue.
30?
Yes,
So it is
sir.
yes.
It's discontinuous at 30.
No, sir. It will be continuous at 30.
Okay, let us see. Let us see. So one of the points you got it correctly, but one you didn't get correctly. So we'll discuss it why you got. So see, in case of 0, your limit is starting from 0. I mean, your starting value is 0, okay? And 0 is inclusive. So you start from 0. After that, you have a circle over here. Then you go up 1 point. So see, at x is equal to 0, it has continuity, obviously, because it is a circular point. It is included. So it is continuous at x is equal to 0. So your discontinuity start from x is equal to 1. So at x is equal to 1, 2, 3, so on, it is discontinuous. Now we will check for x is equal to 30. Okay. So for that, we will go at 29. So at 29, it will be somewhere like in the top and it will go something like this. Okay. And when you get the value 30, it will be over here. Do you all agree? It will be something like this.
Yes, sir.
So just look at the point 29. It is discontinuous. And at 30 also, it is discontinuous. Because see, if you look at 30, at 30, the point is over here in the top. See, at 30, the point is over here in the top. But at 30, this line is not being a part of this point. At x is equal to 0, this line, x is equal to 0, is being included in this. But over here, it is not being included in this. So x is equal to 30, it is discontinuous. But at x is
Yes.
equal to 0, it is continuous. Right, everyone?
Yes.
sir. Sir.
Do you agree, everyone?
Yes, sir.
Okay. Okay. Great work. So how many points do we have? 1, 2, 3. How many points?
30, sir.
30, sir.
Okay. So let us just move one step further in the question. So now it is given to you that f of x is equal to greatest integer function of x by 3. And now I am restricting my limit to 0 and 30. Now check. We'll get something different definitely. So 0 and 30, they were included in the previous question, right? We had square brackets. So they were included. But what about this case? They are not included. 0 and 30
Yes.
have not been included. So if 0 and 30 both are not included, what will happen is my curve will start from the immediately next number after 0. So like it will start from the immediately next number after 0.
1.
No, the immediately next number after 0 is not 1. Right? It is not 1. It is 0.0000 something like 1.
Yes, sir.
Yeah. Something like this. Do you all agree?
Yes, sir.
So over here, the only issue is that instead of x, you have got x by 3. So if fractional part of x is discontinuous when x is an integer, so fractional part of x by 3 will be discontinuous when x by 3 is an integer. Really simple, right?
Yes, sir.
Yeah, like it is divided by 3. So obviously x by 3 should be an integer. So can you tell me what are the possible set of values where x by 3 is an integer? So x by 3 is an integer. So x is equal to 3 times of an integer. So multiples of 3. What are the possible multiples you have of 3 in 0 and 30? What are they? What are they? Tell me.
6, 9, 12,
3,
15,
6, 9, 12. Okay. So on
15
till
till
27 and
7 years.
right.
Yes, sir.
Yes.
And you have got two values that you will need to check specially. So first value is 0 and the last value is 30. For these two values, you will need to check. You will need to check. So at 0, it is clearly visible. At 0, is it continuous or not? Tell me. First of all, is 0 even in your domain?
No,
Is
sir.
0 a part? So if it is not a part of your domain, why should be included here? Why should it even be an issue if it is not a part of my domain? Something that is part of my domain can cause me issues. If something is not a part of my domain, how can it be an issue to me? So 0 will not be included over here because it is not a part of my domain. Now let us look at 30. Okay.
Sir,
Let
it
us
is
look at what will happen.
included, no, sir.
What?
They also not
Great.
included.
Great. Great. If it is not included, it can't cause me any issue. So I only have these numbers 3, 6, 9, 12. How many numbers are there? 9 numbers, right?
Yes,
Nine
sir.
numbers, sir.
So I've got 9 discontinuities. See, like the only point is if x is equal to 0 and x is equal to 30, if they are not a part of my domain, how can they cause me an issue? And how can they be a point of discontinuity if they don't exist inside my domain? Okay, so great. Let us do one really good question. Uh, just a minute. Great. So I hope this question is visible to you. So you have got f, its domain is -1 and 2. So can just anyone fast tell me, are -1 and 2 included in this or not? Is -1 and 2 included in this or not included?
Sir,
Yeah, tell me.
included.
Included, sir.
Included.
Included, right? -1 and 2 both are included, square brackets.
Yes,
So you
sir.
have got f of x is equal to 2x square plus x plus fractional part, sorry, gif of x square minus gif of x. This one is really special, I feel. So first of all, like yesterday, I had given you one small thing to see. If you have got two functions, f of x plus g of x, two functions, you have f plus g of x. Okay. So if f and g both are continuous, if f and g both are continuous, so this whole function will also be continuous. So it
Yes,
is
sir.
asking me what are the points at which this is not continuous. So see, we have got this function 2x square plus x. Is it a polynomial? 2x square plus x.
Yes, sir.
Yes, sir. It's a
Yeah, right?
polynomial.
It's a polynomial. So this function can never be discontinuous. Do you all agree? Polynomials are continuous at literally every point.
Yes,
Yes, sir.
sir.
So this can't be an issue to me. So issues will be caused only by these two functions. Do you all agree with that also?
Yes, sir.
Yeah, so just let us study these two functions only. So for the time being, I can just take greatest integer of x square minus greatest integer of x. Right? Everyone?
Yes, sir.
Okay. So you have got your x is belonging from -1 to 2. So if your x is belonging from -1 to 2, can you tell me what will be the range of your x square? What will be your range of x square?
1 to 4, sir.
1, 4.
Are you sure it will be 1? 1 to 4. Think again.
Yes, sir.
Think again. It is -1 to 2. It will be 0 to 4, right? Because you have 0 also. In this, you have got 0 also, right?
Sir.
-1 to 2, 0 is also part of this thing, right?
Yes, sir.
Yeah, so 0 to 4. Because you have got all numbers. So it will be from 0 to 4. So can you tell me, I have got greatest integer function of x square, right? And x square belongs from 0 to 4. So what can be the points? So see, I have got greatest integer of x. It is discontinuous when x is an integer. So now I have got greatest integer of x square. It will be discontinuous when x square is an integer. So I need to focus on all those points where x square is an integer, where the square of x is an integer. Great. And also, along with that, I have got a minus fractional minus GIF of x. So I will need to look at that also. So if x is belonging from -1 to 2, what are the integer points of x? What are the integer points of x? Tell me.
-1, 0, 1,
1
2.
and 2. Right. -1, 0, 1, and 2. Great.
2.
Great work. Right?
Yes,
Out of
sir.
these, I feel the 0 case is really easy to evaluate. Like it is really easy to calculate, right? Do you agree? The
Yes,
0
sir.
case is really easy. So let us just start with the 0 case first. We have got 0 case. So x is equal to 0. So tell me, if x is equal to 0, what will be the value of y?
0, sir.
0,
Great.
sir.
What about 0 plus? You take a value that's just greater than 0. Where will it go?
0.
0.
0. Great. What about 0 minus? This is a special case, I think.
1.
No,
Yes.
wait. See, 0 minus. Okay, you have 0 minus. So what will be the square of that thing? What is the square of 0 minus? Where is it positive or negative?
0.
Positive. Positive.
Positive, sir.
Great. Okay, great. So
0, sir.
you need to
Y.
take the GIF of that. Again, it will bring it to 0. And then minus. What is the greatest integer function of 0 minus? GIF of 0 minus. What is the
Sir,
GIF of 0 minus? Tell me. Okay, so like you have this 0 over here. I'm talking -1. Great. So this whole value y becomes 1. Y is equal to 1. So you have got at x is equal to 0, y is 0. At 0 plus it is 0. But at 0 minus it is 1. So it is discontinuous, right? Everyone,
yes,
it is discontinuous at x is equal to 0. So the first point of discontinuity, you got x is equal to 0, right? You have confirmed for x is equal to 0. Great. Now tell me, which value do you want to check for? Should we go for 1? Should we go for 1, everyone? Should we go for x is equal to 1? So tell me, x is equal to 1. What is your value of y?
1,
0,
sir.
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 Arey, why 1? It will be 0, right?
0,
1
sir.
minus 1. Great. Now let us take 1 plus. 1 plus. A value that's just greater than 1. What will it be? Again, 1 minus 1, right?
0.
0,
Minus 1, 0. Great. Now, so you are taking a value just smaller than 1. So can you tell me what will be your GIF of x?
-1.
GIF of x will be -1. You are taking a value that's just smaller than 1. What will be your value of GIF of x? Greatest
-2.
integer function. -2?
0, sir.
0. Yeah, 0. And what about x square?
0.
Great.
0.
Why will it be 0? Why will x square be also 0? Can you give me a reason
1,
for that?
2.
No, it will be 0 only. But why is it 0? See, it is really simple. You square a number, that's lesser than 1. So it gets even smaller. So if you square a number that's between 0 and 1, it remains in that range only. So again, y is equal to 0. So can you tell me, at x is equal to 1, is this continuous or not?
Yes, sir. Continue.
It is continuous, right? So this point got cancelled. Now let us check for, okay, so this one is really special. Let us check for x is equal to 2. Can you tell me what is the value x is equal to 2?
2, sir. Y
2.
is equal
Okay.
to 2.
4 minus 2.
sir.
Great. 2. Okay. Now tell me 2 plus
2 plus
2 plus.
equals to 2. 2.
First of all, I know
0.
like many of you will make this error. Is 2 plus included in my domain? Think back.
Yes, sir.
2 plus is a part of my domain.
No,
2 plus
sir.
means what? 2
No,
plus
sir.
means a number that's greater than 2. Do you all agree? 2 plus means
Yes.
a number that's greater than 2. So
Yes,
what is
sir.
the range? What is my domain? My domain is ending at x is equal to 2.
Yes,
This is
sir.
my domain. My domain ends at x is equal to 2. So I can't check for 2 plus. It makes no logic for me to check at 2 plus. So should I be checking for 2 minus?
Yes, sir.
Yeah, I will need to check for 2 minus. And I will need to check if both of them both of them have the same value or not. So can you tell me 2 minus a number that's just smaller than 2? What will be the value of its x square?
1, sir.
1.
GI.
Are you sure? Think
0.
back, think back, think back. No. See, a value that's just smaller than 2. What will be the square of that value?
Smaller than 2.
Smaller than 2. Square, like, uh, see, x is just smaller than 2. So x square will be just smaller than what?
2 square.
2 square. What is 2 square? 4, right?
4, sir.
So that means x square is a value that's just smaller than 4. So what will be its GIF of x square?
3,
X
sir.
square is, great, 3.
3, sir.
Because it's just smaller than 4, right? It's just smaller than 4. So it will bring it to 3. And tell me, 2 minus a value that's just smaller than 2. What will be the value of its GIF?
Sir.
1.
1. Great. So y is equal to 2. So y is equal to 2, y is equal to 2. So at x is equal to 2, is it continuous or discontinuous?
Continuous, sir.
Great. It is continuous. So
Yes,
it is
sir.
continuous at this point. It is continuous at this point. Great. Now let us check for x is equal to minus 1. So tell me x is equal to minus 1.
Y is equals to 0.
Okay. Are you sure? Are you sure?
Yes, sir.
Why? Why will it be 0? Because it is x square, right? What is x square? If x is equal to minus 1, what is the value of x square?
1, sir.
So what is GIF of 1?
1, sir.
1.
GIF of 1 is 1. And what about x? GIF of minus 1?
2, sir.
Same, sir.
2. Y is equal to 2. So
Yes,
it
sir.
is 1 minus minus 1, right? 1 minus minus 1.
Yes.
So
Yes.
it is 1 plus 1. Okay. So should I be checking for minus 1 minus like a value that's just smaller than minus 1? Should I be checking for that?
No, sir.
No, sir.
No,
Why
sir.
why should I not check for that?
Minus 1 plus.
Sir, it is
It
Why?
is ending
Not the domain.
minus.
It is not a part of my domain, right? My domain ends
Yes.
at minus 1. Yeah. So a value that's just greater than minus 1. This one is really special. A value that's just greater than minus 1. So the square of that value, will it be lesser than 1 or will it be greater than 1? I
Is
take a
equal
value
to
that's
1, sir.
equal to will be when it is equal to minus 1. Think. see, take I'm taking a value that's just greater than -1. Okay. So it's -1 plus something, and I'm squaring it. And I'm asking you, is the value of this square greater than 1 or lesser than 1? Tell me. Who will tell me? Shriram, Bhavna,
Greater, greater than 1, sir.
Yes,
greater
sir.
than
Great.
1. Greater than 1, sure.
Yes, sir.
Tell me, why do you think so? Tell me. You take any value
X is greater than
between,
-1.
yeah, it is greater than -1, right? So it is closer
Yes,
to 0. It is closer to 0. Think again. It is greater than -1. So it's
yes,
closer to 0 actually. What do you think? Should x square be greater than 1 or should x square be lesser than 1?
Greater than 1.
Why do you all think that it should be greater than 1? It is on the negative side, right?
sir.
Yes, sir.
It
Yes,
is.
sir. Less than 1.
No, like I don't want you to like see. According to me, it is lesser than 1. Okay, so just think of it like this. In the positive side, you take a number 1, and then you take something that's just lesser than 1. Do you agree that both of these cases have the same meaning? Because when you square it, square is actually symmetric about x is equal to 0. Square is symmetric. Okay. So now tell me. Now think in this way and tell me. Not able to think. Anyone?
Sir, it will be lesser than 1.
Can you tell me a reason for that? Like I don't want you to agree with me just because I
Maybe
am saying. Why do you think so? Why? Just because I told, that's why.
no, sir.
So tell me, like you must have thought something, right?
Yes, sir.
How so tell? Who will tell me? Sofyan, Sriram, Sravani, what do you think? So, see, according to me, it is lesser than 1. And why I will tell you. See, do you all agree that x square is symmetric? X square is
Yes, sir.
symmetric about x is equal to 0. Okay. So, if I take a number that's just smaller than 1, so the square of that, number, is it greater than 1 or lesser than 1? Tell me. I take a number that's just smaller than 1. So, the square of that number will also be lesser than 1. And the same thing we are doing in this case, but over here it is in the negative side. So the number has to be positive, has to be just greater than -1, right? Because it has to be symmetric. So if I am moving left on right side, I have to move right on the left side to make it equal, to make it symmetric. This is how it will work. So x square is actually lesser than 1. So if x square is lesser than 1, my GIF of x square will be 0 minus. And then I have this number over here, this number. So a number that's just greater than -1. So it will bring back the value of GIF to -1. So 0 minus -1. So 1.
Plus
Y is equal to 1.
1.
Y is equal to 1. So can you tell me at x is equal to 2, at x is equal to -1, is my value continuous or discontinuous?
Discontinue.
Discontinuous.
Great.
Discontinuous.
So x is equal to 2. I got my other point. Now we have completed those points where GIF of x, we wanted that to be an integer. Now we need to check of x square also because x square is also possible to be an integer. So x square is belonging from 0 to 4. So from 0 to 4. Can you tell me what are the points at which x square can be an integer? These are all the points. Do you all agree?
Yes, sir.
Yes, sir.
Right? These are all the points. Out of these points, we have already checked a few. Can you tell me which of these we have already checked? Which are the points we have already checked? Just look back.
0,
So if
1,
we
2.
look closely, 0 also we have checked, 1 we have checked. Have we checked 2? No, we have not checked 2.
2 plus
We have we
we-
have checked for x is equal to 2, not x square is equal to 2. We have checked the value where x is equal to 2. So we have checked for x square equal to 4. These are the values of x square. Okay. So two values are remaining. What are the two values? One value is x is equal to square root of 2, and the other value x is equal to square root of 3. And I want you to check it for homework. Can you check it? Square root 2 and square root 3. You can do it. I want you
Yes,
to
sir.
check. I want you to check x is equal to square root 2 and x is equal to square root 3. At which of these points it is not continuous? And then tell me the final answer. That how many points are there? So we have totally calculated 2 points at which it is not continuous. So I want you to check for these 2 points also and tell me what is the answer to this question. Fine? Everyone?
Okay,
Okay.
sir.
Okay, great. And like I might be busy somewhere, so I just want you to show a platform. So
Yes,
see
sir.
this. No, ma'am, I'm not telling. I'm
Okay. Okay. Okay.
Yeah. So see, everyone, we have got this site of exam site. Okay. So just go to this site, search for JEE main, and you'll get chapter wise previous year questions of all the chapters you wish to look for. So in this, just move to calculus and check for limit, continuity, and differentiability. So for a few time, I might be away. So we will be able to like take some classes, but I will not be able to teach because I won't have my laptop with me. So I want you to be able to be solving questions related to continuity. See, we have got many questions related to continuity, to limits. So in this week till Saturday, our next class will be on Saturday. Okay. So till then, I just want you all to solve all of these questions and like we will be taking classes. I will be taking classes on Monday, Tuesday, Wednesday, but I will not be teaching anything. I want you to come up with the questions, any doubts you have in these questions, so that we can solve these doubts. Okay, fine, everyone. मतलब मैं पढ़ाऊंगा नहीं मैं
Yes.
चाहता हूँ कि आप लोग क्वेश्चन सॉल्व करो आप लोग क्वेश्चन सॉल्व करो और मतलब ये डाउट्स लेके आना आपने इन क्वेश्चंस में जो भी आपको डाउट्स हो वो मेरे पास लेके आना मैं वो डाउट्स क्लियर करेंगे इस वीक में फाइन बिकॉज आई वोंट हैव माय लैपटॉप विद मी सो आई वोंट बी एबल टू टीच इज दैट फाइन एवरीवन दिस इज योर वर्क फॉर द वीक
ठीक है,
ओके
सर.
सो दिस इज इट ओके ओके श्योर ओके सो फाइन दैट्स इट ग्रेट मैम प्लीज एंड द क्लास इज ओवर चंद्रिका मैम
Yes, sir.
yes ma'am please end the class
Okay, sir. Okay. Thank you, students. And tomorrow we have class after 6. I will update in the group. Tomorrow we don't have early morning at 5. We have after 6. I will update in the group.